Hey there, and welcome to BridgeText.com's tutorial on Spearman correlation in Stata. Now, some folks have heard of Spearman before, some haven't. Typically, Pearson correlation is what turns up a whole lot. And in order to motivate the potential reasons for using Spearman, I'm going to show you a kind of exception, or let's not call it an exception, let's call it a case that isn't particularly suited for Pearson correlation in Stata. Now, what I've done in the background here while talking to you is I've actually just pulled up a data set from StataPress using this command here, and I've just described it for you so you can see what it looks like. It's data on 50 states. We have 5 variables, and 2 of them are median age and the marriage rate. So the command here, pwcore, that's Pearson correlation in Stata. Then you follow that with the variables that you are correlating, put a comma and then sig for statistical significance. And so now what we see is there is not a significant correlation here because 0.9941 is the p-value. Notice that when Stata generates these matrices here for Pearson correlation, the very first number here is always the R value, and then below that you get the P value. So here the R value is 0.0011, and it is not significant because P is 0.9941. And note that we would need something below 0.05 here for statistical significance. Now I'm going to create a scatter plot to try to understand this relationship a little bit further. And let's wait for that to pull up. And what's going to happen is you're going to see that there's an outlier that's creating a problem in this data set. And that outlier is up here. Notice I didn't label them because these are states, but I just actually happen to know, and we could confirm that, that's Nevada. So why do we have Nevada here for people not from America or people who just don't know this? Nevada is a very, very, very easy state to get married in. People go to Las Vegas all the time to get married. That's why we have such a high marriage rate over here. So it's a super, super outlying value here that could be messing up our analysis. So what do we want to do with that? For the moment, let's just X out of that. And what I want to do is I want to rerun the analysis this time, but without Nevada. So I've done a couple of things here, and here's a good opportunity to show you some stuff in Stata coding. I've sorted on the marriage rate variable. So here's what that's going to do. That's going to put the value number 1 being the lowest marriage rate, and value number 50, because remember we have 50 values in the data set, as you can confirm by looking up here when we described it. So when we issue the sort mrg rate command, it's automatically going to put Nevada in position 50 because Nevada is the state with the highest marriage rate, which we just found out, or I told you. And now I'm going to alter my Pearson correlation command here so that I'm only looking at states 1 through 49. So this was just a kind of a handy way to get rid of Nevada from the Pearson correlation and see what happens again. Well, oh my gosh, you can see that it changed. It completely changed, right? So let me scroll up. You notice that when Nevada was in the data set, we had a non-significant correlation. Now that we have dropped it, we have a significant correlation. And that correlation is negative. So median age and marriage rate are negatively correlated, and it is statistically significant. Now, here is why we might want to do Spearman when we have a huge outlying value, the elimination of which can completely change your Pearson correlation model, as we just did. We might want to move to Spearman because Spearman does ranks. It doesn't do raw data, and so theoretically, that makes it a lot more attuned to data where you'd have like one gigantic outlier. And notice that Spearman's rho, which is the equivalent of Pearson's R correlation value, is again, it's about 0.49, and that is pretty similar to what we had here with Nevada excluded. But notice that this value for Pearson's rho includes Nevada in the model. So what does that mean? It just means that because Spearman is looking at ranks and not just raw numbers, it didn't go crazy because of the one outlier. It just did a better job managing it. and it sort of correctly knew, because it was working with ranks, that hey, Nevada shouldn't screw up the whole correlation model for us, and so it ended up being pretty useful. Therefore, you'd want to consider it. Now, you want to consider Spearman's correlation also when you have ordinal data. So let's say that you're measuring a correlation between the order in which students finish the test and then their score on the test. But in this case, I also showed you that it can be pretty handy when you have a single big outlying value.